Good afternoon, everybody, and welcome indeed to this, the first of a series of 3 webinars presented by the network of USpace demonstrators, looking at lessons learned in implementing USpace and conducting drone flights in a beyond visual line of sight environment. Delighted to welcome you all today. My name's Robin Garrity. I'm the Senior External Affairs Officer with the CESAR joint undertaking, and it's been my privilege to work with the network of demonstrators since pretty much its inception. And we've seen a big change in the world of USpace over the last few years, going from very much an exploratory research environment to seeing many trial deployments and indeed full-scale, even national deployments of USpace and USpace-like environments starting to appear. The purpose of today's webinar is to introduce you to 2 examples of these developments with 2 speakers who will present you with very different insight into the developments that have been going on. Before I take you to introducing the speakers in detail, I'd like just to cover a few admin points. Firstly, there will be an extensive period for questions and answers and discussion at the end of the event after both speakers have presented. Please do submit your questions on the Q&A tab of your Zoom window. You'll see a chat window there. Don't use that. Use the Q&A tab and your questions will be picked up. We'll try and answer all in discussion, either specifically or in a more general way. But if somehow we can't do that, then we will get some answers to you after the event. And indeed, both the speakers have kindly said that they are prepared to hear individual questions from you, and you'll find their email addresses in their presentations. After the event, we'd be very grateful if you could fill in a poll to tell us what you thought of the event. And in fact, you'll find that a web window will open in your browser with the poll some 10 minutes after you first connected. So I ask you please not to fill it in until you've heard what the speakers have to say. But nevertheless, as soon as you've heard what the speakers have to say, then you can complete the poll at your leisure. We'd be very grateful for that feedback. So let me introduce you to today's speakers. I'll just share my screen. Our first speaker is Nikolai Jelev, who's the project lead with the Wind Racers Ultra development. He'll be talking to us in the lessons learned from the Scilly Isles in the United Kingdom, BVLOS air bridge. And you'll see there's a very practical element to this, and I think you'll find it a very interesting story. And secondly, we'll have a presentation from Libby Bahat. He's the head of the Aerial Infrastructure Department in the Israeli Civil Aviation Authority. And he'll be describing for us some large-scale demonstrations in Israel, sharing some experience and conclusions from what they've achieved so far. Once again, what's very interesting, as you'll explain, this is actually very close to what should be a definitive USpace type implementation they're going for. So this has actually got some very interesting lessons learned for any kind of state deployment. So with no further ado, what I'd like to do is introduce you to today's first speaker, Nick Jelev. Nick is the project lead on the Wind Racers Ultra development. He's a qualified UAV operator and has been involved in development of operational procedures for BVLOS missions. Prior to this, he completed a PhD in aircraft design optimization and led the development of avionics hardware before the first flight of the system. In his spare time, he flies gliders and has competed in a number of competitions. So you see, Nick has a vested interest in getting this right. Nick, please.
Hello, thank you. I'll share my screen now. Thank you very much for the kind introduction, and I'm very happy to share the lessons learned from our operations in Cornwall in the Scilly Isles. Good afternoon here from sunny Southampton. A quick introduction about who Wind Racers are. It's a non-for-profit organization set up in 2016. The key aim was really aid delivery to remote places using unmanned aircraft. The organization helped develop the Ultra unmanned aircraft, which you can see in the 2 pictures to the right, first flight of the aircraft was in 2019, the first beyond visual line of sight shortly after in 2020. And what I'll be talking today is the first scheduled cargo delivery service, which is what we did at the Scilly Isles earlier this year, how we achieved it and what we learned from it. In the meantime, we do a lot of beyond visual line of sight flying within the UK, mostly in the south, and we're very experienced in this particular field of operations. So we operate the UK's largest civilian unmanned, uncrewed aircraft. Its design philosophy is to, with no single point of failure, it is a multi-redundant system which has been designed specifically to carry cargo. So it's all about ease of access, ease of loading, and all of the operational challenges with transportation of cargo. It is fitted with the latest ADS-B and electronic conspicuity detection devices. And it is within the UK's CAA regulatory category of specific. So we are designed really to be really reliable, robust, and economic from that aspect. So the Scilly Isles, the Isles of Scilly Air Bridge project was funded by a government body, the Innovate UK, and it really, the project aim was to demonstrate a regular scheduled delivery service of goods from Cornwall to the Isles of Scilly. The challenge here is its regularity of service at a set fixed point of time. So not when the weather's great, not when the aircraft is designed to be decides to be reliable, not when there's other operators in the air, but realistically you take off at a point of time and you meet that schedule to the minute. And we really largely achieved that. In fact, it was an absolute success, and I'm glad that I'm here to talk about the lessons learned from the project. So in the UK, to deliver this type of project, the first thing you have to do is you have to so for a beyond and visual line of sight operations, the first thing that you have to do is you have to identify who are your stakeholders within the airspace that you're going to operate in. So you saw briefly on the previous slide where and the length of the operations that we achieved. But to do this, what we had to do was really identify a number of stakeholders that are operating in this area and contact them. So for this particular mission and the bit of airspace that this required, there were 47 individuals from 28 different organizations, which generated 15 discussion streams. So what that really means is that you have to, before you go beyond visual line of sight flying, you have to identify who are you going to impact with your operations. And then largely in the UK, most organizations, including our own, to be able to do beyond visual line of sight flying, you have to set up something called a temporary danger area, which many of you will know this, is effectively a block of airspace that segregates you from other air users. And the design of the temporary danger area isn't necessarily driven by what you want or what we wanted. It's mostly driven by the stakeholders that you're going to impact by your operation. And finally, the last thing that you do is you submit a scrutinized safety case to the CAA that effectively work with you and make sure that your operations are going to be exactly as you say they're going to be and exactly as safe as possible. And those are really the three steps for doing beyond visual line of sight flying at the minute. And this is the process that we followed. As you can imagine, it's quite a lengthy process. There's so many stakeholders involved, even for this relatively simple bit of airspace, which is out at sea and out towards the tip of the UK. We were constrained to operate between 6 and 9 o'clock. Now, this was perfectly adequate as this was in the operations brief of the project. So we wanted to stick to a very thorough schedule. But our operations were height restricted. And again, this was very much done with our, when we were speaking to other stakeholders. We were required to fit a mode S transponder to the aircraft, which again was another benefit of the stakeholder engagement, so that we're visible to ground radar deconfliction services. And very much so, we had to provide a very, very complicated way of telling ground air deconfliction services of exactly where we are at each point during the operation. So if I talk you through the operations, we broke down the temporary danger areas in a number of segments. So the aircraft on its outward journey was positioned at an airfield on the coast called Perranporth. And there was a radio operator based at Perranporth there to provide deconfliction services in the local area. Once we took off, the aircraft would transition to segment E, and we would hand over to a radio operator at Newquay that would track us on radar, mode S, and that would provide deconfliction services in segments E, D, and C. When we completed, when we transitioned between segments C and B, we would hand over to a third radio operator, and this is a ground-based radio operator that has got nothing to do with wind races, but rather the airfield's infrastructure. And that third airfield operator would provide a deconfliction service for the third leg of the journey. And we would then land at St. Mary's. So we were extremely controlled in our operations. We were communicating via radio at all times of our positions. Restricted in terms of the times of day we were operating, height restricted to some extent, as you can see from the bottom window. And we were broadcasting on 2 electronic conspicuity services, so that is ADSB and Mode S. And very much so, the design of this operation was driven by the stakeholders, who are relatively, and in many ways so rightly so, wanted to segregate us from their operations. That had a number of challenges from our end, organizational challenges, which were ultimately overcome. But it was a very complex bit of aerospace to organize. And there's certainly a number of ways that it could be simplified in the past. So what I'll do now is share you the main lessons learned from this operation. So the first thing from the stakeholder engagement that we did at the beginning of the project was that a lot of stakeholders had conflicting requirements. A lot of them wanted us to fly very high, some wanted us to fly very low. And really we should be aware that there are potentially also other perceived vested interests of operators trying to restrict UAV operators as much as possible, other operators, for other reasons. We were time segregated and geographically segregated. So in the 4 weeks that we operated the continuous service, we saw no other aircraft in the airspace while we were operating. So realistically, the level of safety mitigation that was in place was significantly over what was required. So in our belief, we would be perfectly able to share the airspace with other air users. The final 2 aspects, radio position updates. So we were broadcasting on VHF to all other air users that would be tuned into the specific frequencies. And we were also broadcasting via electronic conspicuity. And the lessons were realistically the broadcasts required quite a lot of manpower from our end and from the other end. And again, seeing no other aircraft seemed almost unnecessary, given that we're already broadcasting on an electronic conspicuity devices. And the lessons learned from ADSB and Mode S, and this is really specific for our application, is that the requirement for us to carry a Mode S transponder was something from an air-ground radio requirement, and it was very, very weather dependent, and it seemed to be affected at lower altitudes than that we were flying, which is another outcome of the stakeholder engagement process. So this really slide summarizes what we found, that because we're not really seeing a lot of airspace use or very limited airspace use in comparison to the center of the UK, where you have hundreds and thousands of flights being completed, we feel that the way forward is really a self-managing piece of airspace, a little bit like Class G is. And I'll talk a little bit about what our proposed solution is for that. The centralized management strategy of UTM was absolutely welcome, but our experience with being controlled by 3 ground radio stations during our operations really seemed very overkill and resource resource heavy, to say the least. So this is what we'll see, and I'll touch about our idea of this in a couple of slides. So what are the next steps? Well, the mission was an absolute success. We carried several hundred kilos of payload, and if you haven't seen the news, we struck a partnership with Royal Mail, so the packages that were being carried, we could see being delivered at the islands at households, which was extremely satisfying. From our point of view, we felt that the risk mitigation in this particular mission was excessive due to the number of the geographical segregation, the time segregation, the radio broadcasts, and all the electronic conspicuity that was in place. And for us to see no other air users in the morning was effectively by design. Our lessons learned from our engagement with other airspace users is really when we think about U-Space and how we integrate unmanned, uncrewed aircraft into the airspace, we really have to consult other airspace users. They hold a lot of power and a lot of water in this, and really how we go forwards, we have to take their opinions and their concerns in place. So finally, and this is the last slide from the Wind Races presentation slide, is what's coming next. And we are involved in a project to deliver supplies and cargo to the various islands in the north of Scotland. And really the ranges and the conditions that we'll be flying will be extremely challenging in the autumn of 2021. Here are a number of the routes that we're planning, and we're extremely excited to deliver on those later this year. So that's really the end from the Wind Races slide deck, but I really wanted to introduce an idea that Wind Races is very much a part of, and it's supporting. We're not the lead, but we are very much a part of, and this is a shared airspace council. What we learned from the Isles of Scilly airbridge was there's really a need to share airspace with other air users. And we really couldn't find a solution that we could implement straight away. And it's something that we thought about quite hard, and we found we think we found a solution that we've just submitted a sandbox application to the CAA, and this is for research purposes. The real problem is that in the UK, beyond visual line of sight operations are currently being almost exclusively done in temporary danger areas. And as a glider pilot and a GA aviation user, temporary danger areas are not scalable. They're hugely unpopular. And while they're a fantastic mechanism for testing UAVs and testing these technologies, they're not really a long-term solution. And so we wanted to create a body, that we've called the Shared Airspace Council, and that's really very much driven by a number of other entities to help drive a change in the UK to develop a class of airspace or a type of airspace that could be used by both general aviation, commercial aviation, and the military and emergency services as one that would effectively remove the need for the temporary danger area process that is relatively clunky at the minute, but fantastic for testing. So the idea is to put a number of high-ranking individuals in a shared airspace council that have representatives from the GA community in the UK, Emergency Services and Armed Forces, and discuss to them an idea that we have, which is what we've called a class Lima. And the question that many people ask is, well, what is class Lima? And the answer that I can say is, well, we don't know. This hasn't been developed yet, and it's not. It's in discussion. But it is ultimately a little bit like a transponder mandatory zone, but not quite. It is a bit of uncontrolled airspace that will allow unmanned, uncrewed air vehicles to share the airspace with manned users and provide segregation based on electronic conspicuity. The key points are really going to be there will be stringent requirements on the design, manufacturing, and operations of the UAVs, and it's not open to all type airspace from the unmanned airspace community. And we are proposing that we use electronic conspicuity completely agnostically, so that all forms of electronic conspicuity are accepted, and there will be a backup for VHF, automatic VHF transmissions from the UAVs. Now, that's really very much the concept of it. The exact details about this are yet to be defined by the Shared Airspace Council and other air users, which will ultimately be impacted by this type of proposal. That would be everything from me. So thank you very much for listening to my presentation, and I will hand over back to Robin to introduce the next presentation. Thank you.
Thank you very much, Nick. A very interesting presentation. I, for one, was very interested to see that you're planning to do something up in the Shetland Islands, where I used to live. I'm very aware of the weather difficulties you might encounter up there, but I think they'd be very grateful, because I'm also well aware of how long it takes to get packages delivered up there. So that will be an interesting development. We have a number of questions already starting to come in for you, Nick, so you may want to look at the questions and answers to prepare yourself. There is a sequence of questions there on operational issues. I suggest that might be an area to focus when we get to the discussion later in the event. But if there are any single answer questions you can do by writing right away, that would also be helpful. So I'd like now to move on to our next speaker. Our next speaker is Libby Bahat. Libby is the head of Aerial Infrastructure Department in the Israeli CAA since 2010. His department is usually in charge of instrument flight procedure design, otherwise known as PANSOPs, airspace design, performance-based navigation, and civil military coordination. In recent years, the department was also assigned with the task to lead the UTM topic. Over to you, Nick.
Hi, guys. Thank you very much for the presentation. Thank you, Robin. You'll see many similarities between my presentation and Nick's presentation. Of course, I love the idea of the Lima airspace, and we can say that we're going to try it within a week. So let me go on. I'm going to talk about the large demonstrations that are going on in Israel. We had a series, we're starting a series of 8 demonstrations. One was already done in March, and I'm going to talk about it. And the second one, again, out of 8, is going to start in a week from now. And I'm going to share what we have already learned by now. I'm going to say a word about the Israeli airspace because it's very complex and very relevant to the issue. The UTM status in Israel, and now we can compare to the EU regulation 664. A little bit about the initiative, and the last 4 slides are the challenges and solutions. I'm going to get to those as fast as I can. So this is the Israeli airspace. The red parts are the parts where usually the Air Force is using low-flying vehicles, so no drones can enter. The entire size of Israel is 440 kilometers, which is 270 nautical miles, by 70 kilometers or 40 miles. So again, someone can measure his own distances driving every morning and see the size of Israel. Red, green dots are where drone bubbles have already started flying in Israel. Size is also an advantage, so we're exploring a possibility of cooperation with the Israeli railways. This is where the major railway lines are right now. And you can see that if you make the proper cooperation between a drone company and the rail, you can cover many parts of Israel and bypass the current technological situation where most drones, the simple ones, don't have a lot of range. So this is one way we're exploring of bypassing the drone problems with range. Israeli airspace, again, is very complex. I'm not going to walk through everything. I'm only going to stop here. On blue is the civilian portion of the airspace. All the other parts are generally military airspace. So you could understand we're working in a very close cooperation with the military. Light sport aviation activity, fighter routes, VFA routes, RPAS routes for many years now, training zones of fighters and transport, very, very complex airspace, and you saw the size. And if anyone is particularly in fond of birds, which I imagine a lot of people in this forum, Israel is known for huge bird migration during the right season. So this is the area we had to work in. 3D and a focus on the central part of Israel. This is Ben Gurion Airport. And this is the area of Hadera city where the large demonstration happened. I'm going to show zoom in later on. If you're looking at the drone or robotics hype cycle, then we remember the different stages: innovation trigger, peak of inflated expectation, through of disillusionment, slope of enlightenment, and plateau of productivity. We started some things in the innovation trigger, the pilot program, the drone delivery of this initiative, and some are more mature. Test sites in the desert, where we test mainly non-GNSS environment, but with other disturbances, deliberate disturbances as well. One could see that the regulation, the final regulations that we're supposed to work by for the next couple of years is not so close. We're talking about a year or so. To the least part now that we have a new government. This initiative, what we call a spearhead of the government, is mainly meant to remove obstacles. Every company, that's what you see in this diagram, that wants to eventually get to making a profit is very limited by the first stage, the left part of the diagram, where a lot of investment has to be made. Not only money per se, but also time and dealing with what they see as obstacles. Sometimes it's not the real obstacles, but this is where we focus our intentions and our trials to remove obstacles from company. At least again, we're a government initiative, not like the firm is saying, we're here, I'm from the government, I'm here to help you. But this is where we focus. Later on, of course, profits will come for the first companies, a large profit, and then we'll get to the perfect competition. I'm not going to go through the entire parts of what the government has to do or what the government companies have to do. Some of them are not normal things governments do, and CAA do not normally do. We do a lot of publicity, cooperation with companies, directly with foreign companies, just to advertise, just to bring to their attention. We are working without the formal laws and regulation as the entire Europe and most of the world, where this regulation is not in place yet. So we have to think a little bit out of the box. Government support, again, very important, is not only out of the money pocket. It's having the time, us as a regulator, having to invest time and to give your time to the audience, to the companies, to this initiative. Time is a very crucial factor. Is being flexible, again, thinking out of the box, finding solution, trying to get things going on and not finding reason to stop. That's very easy. Accessibility is something very important. If every company has my cell phone, my WhatsApp, I answer them most of any hour, that means a lot. Reaction time, eventually giving them answer, yes, no, exactly why not, and what could be changed very fast, sometimes within hours, sometimes within days. That means a lot. That's a very important government support. So a steering committee has been established. Is some of the bodies you see here are not normal for something which is an aviation project. So you see Ayalon Highways, our highway authority, as an execution body. You see there the Israel Innovation Authority, health communities. It's very important to know who has an advantage in some part and not treat your ego as a civil aviation authority that theoretically has to deal with anything, with everything, and giving for example, the highway authority or the Israel Innovation Authority the lead if they have a certain advantage. I'm going to say a word about it in the end as well. Objectives eventually is accelerating the ecosystem, very large-scale economical impact, a regulatory framework, again, of combining the companies, the customers, looking ahead, of course, at the final market you want to build. International community, we're getting a lot of assistance from the World Economic Forum. And something that's unique to Israel in our objectives is our unique GNSS environment that has a lot of interference. Our very good C2 technology. Time to market is small because of number of companies, because of our access, the direct relationship between us and the companies. Again, an advantage of a small market. This is, let's say, 5 big directions of the national drone project. Starting from left to right is the test center in the south part of Israel in a desert environment with no GNSS environment, with other interferences to test mainly this subject. A tender that we did, call for tender only for USSPs and control centers to have this market moving, to have people think, to have us think, and try to make decisions now. The main issue that I'm going to say a word about later is the large-scale demonstrations. So we talked about it, 8 large-scale demonstration at the end of each quarter for 2021, 2022. 1 is already behind us, 7 more to go. 2,000 flight per demonstration in the March one, and probably we'll do more, maybe 2 cities, 3 cities in the September and the December demonstrations. We use this committee, the steering committee, for 2 interesting situations. One, the pandemic. We changed a couple of routes and used the drones to deliver vaccines, to deliver blood samples within hospitals, between hospitals. And another thing we did during the last conflict is have drones check rooftops and neighborhoods to see where rockets fell. Sometimes one could have a hole in his roof from a debris and not knowing it until you have a drone looking over there. A word about the Israel special regulatory situation. We're not US, we're not Europe, so in some way it's an advantage. We can pick the laws that we seem fit to Israel. So in personal licensing, we took the Part 107, for example. In terms of UTM U-Space, we're going to follow as strictly as we can to the EU regulations, 664 and other. This is something that is a big advantage for us. Zooming in on the project, so this is the city of Hadera and the fields around it. We divided it into 5 different areas for 5.5 different companies, and started making tens and hundreds of flights every day, crossing between the zones, everything BVLOS, everything on the cloud, with a control center that can see everything and control everything, and can give you conflict alerts, a collision alert. You see one in the right bottom screen. Crossing infrastructure, I'm going to show it in a second. Very aviation every day, briefing, debriefing, escalating demands. Eventually, we want to demand to simulate a guy ordering a hamburger and having the drone deliver what he had to deliver within minutes. So this is the general area. Take a look, a special look at the top left, because I'm going to show a small animation of these 2 top left areas in a second. This is an example of 2 drones from 2 different companies. You see Airways and you see Highlander that were intentionally in crossing routes, and we hope that the system will alter their routes in order to avoid a close encounter, which it did, of course. The other thing you can see here is crossing a major railway infrastructure. And later on, they continued to the west part in crossing a major highway in Israel. We're talking about the triple GNSS systems, parachute, and of course, cooperation with the first responders, just in case. This is the control center. It was set in Haifa, which is north of the experiment, the Hadera city. The next one, which is starting in a week, is going to be in Tel Aviv, but again, controlling the same center. We followed closely, as we talked about, the European regulations, the blueprints, the types of airspaces. This is demonstration, an animation that was prepared by AGL Aviation, a consultant company we're using. Remember the top 2 left parts in Hadera city. This is our they broke apart between the different classes, the different types, Y, X, etc. You can see an uninhabited area and a medium risk where the power plant is. The highway is red. Now we're taking a sharp right turn toward the direction 180 to the south part of Israel. Again, all this was actually flown, almost 2,000 flights. The airspace assessment that AGL prepared for us, so you can see the VFR routes, a couple of segregated areas, the ground, the terrain, where drones can and cannot fly, and obstacles that are known, cellular antennas, building trees wherever I have the information, and eventually figure out which areas a drone can fly and cannot fly. Last 4 slides with the main lessons learned. So we're talking about almost 2,000 flights. Some were simulated. Again, something you should think about when preparing these demonstrations. 5 different companies. In a week from now, the second demonstration is going to be more a single USSP, and we're going to switch it every 2 demonstrations, switch the USSP. We talked about earlier, Nikolai talked about uncooperative traffic. Should I completely segregate? Should I use Lima airspace? Should I TRA? So we're kind of using Nikolai concept of Lima. Many of the tools already are using some application. The gliders are using FLARM. Our motor parachute are using their own cellular application, and cooperating between those two allowed us to have the motor parachute location presented in the control center. And a week from now, we're using a different simulation, a different application of actually getting inside the system. We'll have a plane flying there, and we'll want to see the drones moving away from his direction. Many visitors in the control centers, something that was an issue. Height measurement is something that we know we have to improve in. Some drones are looking at their reference surface as the place where they took off, and then if they have to fly 3 miles at land somewhere else, we saw it's an issue that's still not perfect. And it's also, for example, an issue when you determine the separation you want from other vehicles. The area where many drones will be landing and taking off, if it's 2 or 3 companies are using the same location, then you have to have some sort of a CTR management, because the drone will have unnecessary alerts one from another. Because of their status, you have to switch the airborne on and off in some cases, even before you put the motors on. Strategic deconfliction is something that is theoretically used in terms of days or weeks ahead, and now something that has to be done within minutes or seconds. Weather and winds, again, you know where you're taking off. But if I'm going 3 miles towards the beach and trying to land there, a situation can be totally different. How do you clean your landing point? Pretty obvious, from obstacles, from people, even animals. How do you choose the exact landing point? Optical, GNSS. We talked about height measurement. Before you go to the mission, do you use some sort of Annex 14 obstacles of some sort, maybe similar to helicopters? Of course, how do you do it in a crowded avenue? It's an issue that many companies are dealing with. Hazardous material. It might not be different than delivering something on a scooter, on a motorcycle, but when it's up in the air, it gets everyone's attention. Eventually, we want to reduce in a way, the expertise of the people involved. If you'll have the pizza manager pushing a mission in his computer, then it's one cost. If you have an operator where it takes off and an operator where it lands, and changing batteries is something that someone qualified would have to do, and everything has a meaning in terms of money. Licensing, drones per controller. Right now, the regulation theoretically allows us only one. Of course, it's very non-economical. Israel has a very tight and busy airspace, as we shown. Air Force, light sport, aviation, helicopters, very active GA community. And I think Nick showed in an excellent way that this is a very major issue. You don't want to take their airspace. You want to try other things, as we are doing. Very high security demands because of our complex neighborhood and the Air Force demands. It's very understandable. GPS jamming, again, something we take almost as granted. I mentioned the number of companies, the accessibility, the size, which is some sort of an advantage, and the part that we are not officially obliged by either of the major FAA or EASA. Last slide is a sort of a checklist if you're an ANSP or a regulator or just an entrepreneur, what needs to be done. So as in many cases, assembling the right team is the first part. In the CAA, it's mainly ATM, us from the ATM section, and the airworthiness. These are, we thought, the more complex problems to solve. You'll have to get the management backup. You want to go to your manager, the director general in our case, and tell them you need to have their backup to give you some freedom, but you need to have to give you backup, and you need to invest a lot of time. We talked about giving the advantage to whatever body is now that has the lead. It might be from that they have the budget, a personal level, the right consultant. So it's relieving all ego. Getting your feet wet is tremendously important. You have to publish RFIs, to make many publications, to reach out. If you don't get your feet wet and start to try experimenting, and then you can stay in the theoretical level for centuries. Experimental tool specific are both two tools that can give you a lot of freedom. So if using them correctly, you can move a lot only using those two methods. Of course, when you get later on, you need to go to something more economical. Look from budget from unexpected sources. Again, we talked about different authorities that may help you, health industry. Join the relevant stakeholders from day one. If you're afraid that the Air Force, for example, might be an issue, have them on board from day one. Reach out to the companies. They are fearing the unknown. Sometimes companies fear to reach out to you, to the regulator. So reach out to them, give them a hand, tell them you're here to help. I know it's funny, but if you get a person on a personal level acquaintance and start working, things will progress very fast. Start with operations, of course, that will enjoy public support, medicine, etc. And get all the help you need. We're getting a lot of assistance from EUROCONTROL, for example, from Elina's team. And we're not too shy to say that we don't know any some certain thing. I think that's about it from me, Robin.
Thank you very much indeed, Libby, for a very interesting presentation. Covered a lot of ground in that time there. And as we can actually see from the question and answers session discussion, there's a number of issues that have been raised by both that and by Nick's presentation. Nick, may I ask you to turn your camera on, please? What I'll try and do is start asking some of these questions generically, where you'll both be able to respond, and then if we need to drill down into a little bit more detail based on your particular circumstances, then of course we will do that. I think the topic that seems to have generated most interest in the question and answer is that of detect and avoid, and there are a number of themes that come out here, and I think we need to divide it into both the what was done in research and development and what you anticipate being necessary during deployment. So really, if I can start with you, Libby, with your deployment and your trials so far, can you let me know what your philosophy was for detect and avoid? Was it a requirement or a nice to have? What technologies did you use? Did you have a need to deal with uncooperative users, and if so, did you also allow unlicensed sensors? I know you did talk about using FLAM, but that does introduce its own complications with not being certified. So I know there's a lot in that question, but what we're looking is really, how did you deal with the detect and avoid requirement? How do you view the requirement, and how would you see it in the longer term future as part of the overall deployment?
The detect and avoid, we know that it's almost not relevant on small drones within our next couple of months or years. So we're looking at the sizes of Matrice 600, Matrice 300. Detect and avoid are not relevant there. We used, as you saw earlier, a city and fields around the city. So we see that in most cases, manned aircraft should not be in those areas. So the conflict between those two is not so strong. The drones eventually should serve people and fly in the areas of the cities. And generally, manned aviation should not be very low or very close to the areas of the city. We didn't use FLARM. FLARM, I mentioned it as a certain application, you can say. It's a system, of course, that shares the pilot's location somewhere. Now, we used another application, a cellular application. We just tested it on March. A cellular application that the motor parachutes are using between themselves, but we shared its location on a screen. And if we knew that a motor parachute is getting closer to an area where drones are, then we told the drones to land or move away, mostly in a manual sort of way. I think the direction that we're going through in June demonstration is very similar to what Nikolai told as a sort of a Lima airspace. We're going to, first of all, we're going to use the cellular application as in a more technical level. It's going to actually technically, automatically move drones out of the way of the pilot. It's going to be a light sport aviation, of course, VFR, 500 feet above the drones, but we're going to test it as if it was lower and see the drones actually moving away from him. It's a demonstration. It's a number 2 demonstration within 8. So I don't claim that we know everything already, but if we want to start working within a year or 2, we have to use of what's available right now. We're not going to do it for operators, air operators, for Airbus 320. But we think in this environment of, this is a VFR bubble. This used to be a place where VFR vehicles could fly between themselves, light sport aviation, gliders, and so and so. So we think it fits there in this part of the world. Maybe not somewhere else, but this is what we saw fit in terms of a replacement for detect and avoid.
Thank you, Libby. That's raised some other interesting questions, which I already feel rattling around in my head. We may need to come back to that. But I think what I'd like to do is just ask Nick to say a few words on this with the same larger question I had. But at the same time, if you think about Libby's answer, some of the ideas that were discussed, like not needing detect and avoid in certain environments, but also having an automatic mode where the drones start getting out of the way of a suitably transponding aircraft, this could be seen as treading on the toes of some form of separation provision or even collision avoidance. So I wonder if you'd like to say a few words about the general question to start with, and then come on to those rather more thorny questions at the end.
Yeah, so the general question is that currently manned aviation is reasonably good for avoiding themselves in Class G airspace, see and avoid. And there is, exactly like Libby said, as we have the tools already, FLARM, ADSB, the cellular network in place, to address the air prox risk the drones, what the unmanned aircraft do by using this technology and use it in a way that the aircraft effectively just move out of the way of manned aviation or automatically disperse. The automation side of things is a different thing that I will handle. The regulatory part of using unlicensed electronic conspicuity modes is really sort of it's not something that, and again, it's not something that I will comment too much about other than my experience with flying gliders in a very small bit of airspace. With gliders, you can have several hundred, well, not several hundred, but up to 100 gliders sharing a very small bit of airspace, and yet they are very well able and equipped to deconflict with each other automatically. And that's sort of the methodology that we're sort of thinking about this Class Lima airspace, is that it's effectively everybody's broadcasting their location and automatically deconflicting. The other issues of whether you need it, well, I would say yes, you do. For our application, for our size of aircraft, you definitely do need a mode to deconflict with other air users, as we pose an air risk, considerable air risk. If you're obviously a small unmanned quadcopter, then perhaps you don't, and that is something that a UTM network can manage for you. But for our size of aircraft and similar size, you would need a form of detect and avoid.
Thanks, Nick. So without briefing, you've got a nice connection there. You mentioned a UTM network and what the UTM network can do. Now, this is a question we saw in Libby's presentation, a large control center with quite a lot of people sitting there. And Libby, prepare yourself. I'd like to ask you a bit about that shortly. But the UTM network is the vision for U-Space is making it highly automated. So now we're talking about the system surveying all kinds of air vehicles, making decisions about them, making them avoid each other. I won't say that this is separation yet, that's too contentious an issue, but keeping them apart in some mechanism using some broadcast technology. Do you see there is a role for a human-based control center? Do you see the automation completely taking over for the smaller vehicles? And in this case, are we going to need certified avionics, or at least avionics and systems that are they're guaranteed to make a certain performance requirement under whatever aegis has proved to be necessary? How do you see all that coming together?
Is that a question for me, sorry, or Libby?
Yes, please. Yes, please.
Oh, okay. So, right, certification. It's a challenging question. So the certification aspect of it is an interesting one. Personally, and I don't speak for the Shared Airspace Council or Class Lima concept. I feel that unlicensed broadcast technologies can be used if there are minimum standards of operation. So it depends on the level of certification that we implement on those technologies. So it may well be that a CE European mark standard may well be enough, which is a fairly easy thing to obtain over a fully certified TSO level certification. In terms of the, sorry, I may have to ask you to repeat the first part of the question, but in terms of the challenges, it's not an easy challenge. And then, sorry, the centralized network. I think in the future, and this is about 5-10 years down the line, drones, unmanned aircraft can be. In fact, it might even be closer to this. Can do automatic avoidance. The algorithms already exist there. They're already implemented in Airbus, Boeing large aircraft with automatic systems. So there's no reason why they can be transferred to smaller unmanned aircraft. The centralized aspect is really specific to the application. So something that's flying in a very congested environment, over an urban city environment, may well require a fully centralized control center to control it and to track its flight path. An aircraft that is flying 15-20 kilometers out to sea in an area that is relatively uncongested can be left to its own devices to do its own avoidance using electronic conspicuity or by other means. There's a reason why we've selected electronic conspicuity. But yeah, so in my opinion, those are two very different applications and they require two different solutions. So that would be it.
Thank you for that. I realize I put you on the spot somewhat there, so thanks very much for taking it on. So Libby, your turn. I was very interested to see and to hear about your control center, which leads on similarly from the question I just asked to Nick. But what were all these people doing? What's their role? And if we talk about a fully automated system in the future, will they still be there? And if not, is it not going to prove to be a very expensive option for managing UTM U-Space?
Well, naturally, we know that eventually all those people are not going to be there. A hamburger joint manager has to be able to send his hamburger in the middle of the night without talking to anyone to a certain yard at the other end of the city. This is a first experiment. This is the first time. I think it's pretty unique in the world. We had, for example, a representative of each company in the room. We talked about having 5 different companies, and we had a manager, and we had someone in touch with the ground control units, the Air Force and the civilian. We had people from the organizations that eventually are managing the initiative, Ayalon Highways Innovation Authority, CAA. I see that in the next demonstration, the second one out of 8, there are going to be less people. Of course, the final goal is without having any one of them. Now we have to remember that we have to keep people relaxed. We have, for example, to keep the Air Force relaxed. We have to keep the ANSP relaxed, that the second they push the telephone button, someone will answer and give them a good response. So we're starting very, very safe with a lot of people. And I think it's an advantage if you get the community relaxed and knowing that you have everything covered, even if it's not efficient right now. I think it's worth a lot of bonus points for the next phases. One thing we have to remind, this was a segregated area. Again, the first experiment, it was a segregated area, the area around Hadera city. I talked about it, how it's not so useful for most manned aviation. And NOTAM, an AIC with a chart, with explanation, and everything was published for the community. But if we're going to expand it, or when we're going to expand it, it's going to be using the methods that Nikolai mentioned, a sort of a Lima airspace with aircraft that will be transmitting, and knowing the risk, will be able to enter those areas. Okay.
Thank you very much, Libby. I think I'd like to just change the tone away from the really complicated technical side for a moment, and let's look at the business aspects for a moment. So, Nick, you did the delivery, and we've heard a little bit about the kind of things that you delivered to the Scilly Isles. Where do you see the business case beyond remote regions? So I guess also in remote regions, do you think there is a big demand for these in the island areas you're looking at, but beyond that, and where do you see it going? And if you could say a bit more about the relationship with the Royal Mail, that would also be very useful. Thank you.
Absolutely. So first of all, the relationship with Royal Mail, the project was a consortium of several companies, which was not Royal Mail. Royal Mail were brought on afterwards, several weeks prior to the missions, the project starting, the crossing starting, and they were absolutely fantastic. So as you saw, our flight started at 6 o'clock and finished at 9 o'clock. So that's with the return mission. The Royal Mail van would arrive at 5:15, drop off bags of Royal Mail, and the Royal Mail van would pick them up on the other side of the island. And really, these kind of flights or these kind of logistics routes are fantastic for these type of aircraft. You really, it's an hour's commute. Well, it's an hour's flight from Perranport to the Scilly Isles. And while it was monitored by 2 ground station operators at the time of the flight, they're really looking at it in 6, 12, 24 months time. There really shouldn't be the need to monitor it as closely as we had done in the past. The flying can be fully automated. So any sort of long range routes that are flying over low ground risk and potentially risk, even high ground risk areas, although that's a point of contention for certification, would be on the business case. Where I see it, island communities connections are fantastic business opportunity. There is also the opportunity for aid delivery for disaster hit areas. Again, that's really what the aircraft was designed for. And there are second business cases as well. So while the aircraft is transporting goods across to the islands, they can also do fishing patrols. They can be equipped with cameras. And there are secondary uses for the aircraft while they're performing those missions. So there's a number of business cases out there. What I would say is we are targeting the difficult to reach areas in difficult to reach environmental conditions. So we're not really looking to compete with a van man from London to Brussels, say, or that are very well connected in very well established road networks.
Can you just maybe add a bit more on the environmental conditions? I'm quite curious about the performance capability in bad weather.
Oh, I don't know how much I can say about the aircraft as we try this, but certainly out of the days that we flew the missions, we were not the 2 days that we effectively had to cancel flying. Both days were also cancelled with the manned operator. So the operator that was linking the islands had also those days cancelled. So what I would say is we're on par with the sort of the medium commuter aircraft in terms of operation. So what I will say is we can fly in rain, and regulatory approval pending, we should be able to fly in IMC sort of fog and sort of conditions that do not allow us to have visual line of sight with the aircraft. Certainly when it's out to sea, that was never a problem. It's a segregated airspace, but during the landing approach is a necessity, is a regulatory necessity, and that's something that we're working towards.
Thank you for answering. Great answer. Thank you. So Libby, can you tell me a little bit more, please, about the business opportunities in Israel? What kind of thing are you trying to enable? Because you've gone almost the other way around. We have with the UK example a particular business case that's being made to work, and you're talking about implementing a UTM system and then putting vehicles on it. So what kind of businesses do you anticipate supporting with this work?
We're not sure. That's where I think one could say we're shooting all over the place. So we're in touch with the health industry. Again, I talked about how right now there's an issue of both cost and public acceptance. So the health industry is a sort of a combination that wins both those needs. Public acceptance is high. Who wouldn't want his liver to fly very fast from the hospital 50 miles away or a couple of miles away when he needs it, or his blood sample or his vaccine, and it's very expensive. So this is a way now to win both the cost issues, which is now very high, and also public acceptance. But we're exploring everything. We did a cooperation with the pizza international company and hamburgers, and we're checking basic supplies, not urgent, but basic supplies between the hospitals. Of course, there's a big cooperation with the Post just started. That's going to happen also soon, I hope. So we're shooting all over the place, making a lot of conversations with many customers. I talked to how us, the CAA, and other government authorities are doing something which normally we're not accustomed to do, making publicity, selling a product. But we're doing it a lot, and hoping that this when people hear of it and see that it works, they'll want to use it by themselves as well. Generally, right now we're putting a lot on different government needs, so post, health, and so on. I suspect that the food industry delivering a coffee is still time to go, or a hamburger. It has to be something right now, something a bit more expensive. So if you're looking at capsules for espresso machines, which you buy for $100, it has to be lightweight. But we're exploring every idea someone has.
Thank you. Just while we're on this then, the regulatory background. Now, you've said quite openly that you're looking to comply as much as possible with the regulations coming out of the European Commission, which is a good news for us. Do you, at the moment, do you actually approve the flights in accordance with the SORA methodology? Do you have your own or a mixture? And secondly, in your attempt so far to do the trials and to design your implementation, have you discovered anything from the European regulations that you don't want to use or that you would like to see a little bit different?
Generally, yes. SORA is the major route that we're taking. The SORA methodology is the major way to reduce the risk. So this is the main channel. If someone sends a perfect Medusa or perfect other method, then we'll listen. But generally, SORA is the way is strictly the way we go. We're trying to analyze the regulation since we are right now with our feet in the water. So we don't have a time to wait to see what's going on in Europe and how does each company develop. And so we're struggling with it right now. It might be the case that the regulation, the main regulation we're looking at is, of course, the 664, the use-based regulation. We're struggling right now with the Common Information Service, more in terms of business case and the fact that we probably will not have many USSPs on day one that will want to take the job. So I don't know, perhaps some parts of the regulation are for 2 years from now, 3, 5, 10 years from now, and maybe we won't be able to implement every word of it on day one. We probably the first USSP is going to do pretty much everything. He's going to be in direct contact with the NSP. He's going to combine between the companies. He's going to be the weather service. He's going to be the flight authorization service, the alert service, and the geofence service, etc. But again, we're studying it. It's difficult. If I would name one, then the Common Information Service is what I'm not sure how to start with on day one. But we'll try. Okay.
Thank you. And just if I may add an extension question to that, you did mention in your slide there the airspace designations that came from the Cesar Chorus project. I'm wondering, have you had much experience now of what that means in practice? Do you find those classifications are actually helpful and useful, or have you got feedback that we should take notice of?
No, I think they are very logical. They are very reasonable. They are very, from my other field of expertise, PBN. They are pretty much performance-based applications. So if I have a very sophisticated drone with a triple GNSS system, Galileo, GLONASS, and GPS, I have a parachute. I proved that I could land with no GPS, none of the 3 systems at all, then I might be able to fly directly over the city. And if I have a less equipped drone, then I won't be able to fly over the cities. So it's very familiar from the performance-based attitude. We found it very logical. And we're using also the experience of the company. So company that is joining the June demonstration for the first time will be only able to fly in open areas, not over the cities, and companies that have more experience and more flight hours in our initiative will be able to make more complex flights. This is something that can be thought, that we might think about, of adding this performance-based and experience-based. It's logical things. We do it in manned aviation. So it might be a good addition here as well.
Thank you very much indeed. Needless to say, the network of demonstrators will be very grateful for all the feedback you can offer us. It'll be very helpful. So Nick, really the same questions to you really about the use space regulations that have come out. How applicable are they to what you're doing? Are they compatible with what you're doing? Would you like to see anything different? And how do you see the chorus airspace definitions, if you have considered them? If not, there we are, why not?
So when we started applying for permission, so we operate within a specific category in the UK. What that really means is that whenever we want to make a new mission, whenever we want to operate the aircraft in a different way, we have to apply directly to the Civil Aviation Authority in the UK, ask permissions, ask their feedback on this, and through a discussion, they give us effectively a regulatory approval to do those missions in accordance to a number of requirements. So this has been going on for since the beginning of the project, since the first flight in 2019. So we're quite experienced in that. The process is somewhat different to the European SORA application process, but I know that the UK CAA are looking to adopt that, and I believe that that's the way forward, and that's something that we would welcome. It's good to have common regulation across the UK, across the world, so that reduces the paperwork from our end and the complexity for operations. The regulations that are coming out, we would still be classified in the specific category in the EU regulations as well. Looking at our operations, it's something that we'd welcome. It's not something that we see as a threat to us. It's something that we see as an opportunity and are fairly happy with. It is not too dissimilar from the process that we currently follow with the CAA. I'd say it gives it a little bit more structure, but other than that, both processes have been reasonably well.
Thank you. I'd like to just briefly talk about some performance. We've kind of touched on it already, but with your communication mechanisms, I'll ask this question first to you, Nick. I presume not presume at all, but what communication mechanisms were you using in terms of direct communication between the vehicle and external stakeholders? What did you find about latency? What was the requirements? Have you recorded your performance needs for it? Was the infrastructure good enough? And any service suppliers for this kind of technology? Did you have a service level agreement, and were you able to monitor it? Really, it's about performance of the communications.
So communications, the aircraft is fitted with 3 modes of communications: radio, LTE, which is the 4G network, and SATCOM. We were primarily using radio for the mission that we were doing. And for our own latency was almost negligible from this perspective. Satellite communication, obviously they have a little bit more latency on that, but given that we had a triply redundant communication system, that's fitted, given that we're primarily using the radio side of things, we didn't really need to test the latency of LTE and SATCOM in this particular mission, because we've had a lot of experience with radio. We are developing the LTE and radio and SATCOM communications as we speak in a little bit more detail, and I should be able to give you a bit more, a little bit more on this next time we speak. The position reporting latency. So it's a strange one. So we never found a latency issue. So when we were broadcasting on ADSB, and so latency was somewhat not of a big problem because it was the ADSB was 100% reliable through every single flight. There was no point that we had a drop in the ADSB feed. So the ADSB feed gets picked up by a network, and that gets broadcast over the internet via third-party software. In terms of the latency on that aspect, we never needed to monitor it in a lot of detail to monitor the latency of third-party websites that broadcast that. What we also have is on the aircraft, we're able to broadcast via the distributed avionics network to somebody who has access to our effectively web page, and we can broadcast the location of the aircraft in real time, and the latency of that is milliseconds effectively. But what we found, and this is quite interesting, is that people really didn't care. The stakeholders really wanted a certified system, and they were only interested in TSO certified Mode S transponders, even though both Mode S and the low latency direct link broadcast from our aircraft were available to them. They were generally interested in a certified system, as that is the regulation, as that is the only legal way of doing so. So there is opportunity here to adopt these methods in the regulation potentially as a way of that.
Thank you for that. Most interesting. And Libby, if I could ask the same question for your experience of performance, but adding, you mentioned in your presentation that everything was in the cloud for the data and sharing. So how did that work, and just performance-wise?
I'm not a technical person, but we had the advantage of all the 5 companies working very closely with the intended USSPs. So they exchanged protocols, which methods, LTE, cellular, and exactly how it worked, what is going, which are the protocols to be exchanged, and so on. Latency was within seconds. But again, I think a very close environment, closely managed between a small number of companies, is pretty easy to manage. It's something that the tech guys from all companies can solve very easily. At this stage, as it is an experiment and a segregated one, very unique, the technical problem was not the main issue. Again, based on cellular, LTE. We're going to use remote IDs, a small box in later experiments, probably start again next week. I hope it covers it. If not, then I can answer later.
Very good. Thanks very much indeed. Now, for both of you, we're approaching the last 7 minutes of the event. What I'd like to do now is to give you both a chance just to spend a couple of minutes with any final messages that you might have. Probably, I'd like to focus on the key lessons learned and where you think maybe we ought to focus based on your recent experience of what you've been doing. And if I could start with Libby, please.
So I'm not sure how many of the audience is regulators, but for a regulator or let's say from the side of the government that want to start your UTM projects up and running, I think it's important to get the right team of a small number of experts, of people that you know that will be behind you, that have the time for it. So assembling the right team from the right stakeholders, a small team, get management approval, and then start getting your feet in the water. You need to get call for tenders. You need to get requests for informations up. You need to reach out to customers. You need to be very active. In our case, the terms of the fundings, I saw someone ask, was generally half and half from the government and half from the companies. It's something that adds a way of showing that you're serious, not just the government funding everything, but having the company as well over there. So this is the place I would start: assembling the team, getting management back up, and getting your feet wet, getting projects up and flying. Until you do that, I think staying in the theoretical level will only get you this far. And sometimes you just need to get to your management and tell them, listen, we researched, we can read stuff for a whole year from now. We need to get things flying. That's my main message.
Thank you very much, Libby. Nick?
Yeah, thanks, Libby. That's really well summarized from the regulatory point of view. From our point of view, we're all about delivering goods across hard to reach places. And that's really what we really want to achieve, is people that are not very well connected, to improve their connectivity in times where they've got poor weather and are difficult to reach places. That's fundamentally why we do it. And we don't want to take away airspace from the general aviation community. We want to effectively work, or general aviation or civil aviation community. We would like to work with regulators to integrate within the existing airspace structure. In terms of regulation, we see this as a very rapidly evolving field, and as a sort of a private non-for-profit enterprise, we evolve to it, and we can meet those regulations, so long as there is still a business case, and so long as there's enough freedom to be able to do this. So I guess the message to the regulators, particularly in the UK, is thank you for all the support that they're putting in, and I know it's a lot of time that they've done, and we look forward to basically the next steps in terms of integration of aircraft and the airspace.
Thank you, Nick. Well, I think we have about 2.5 minutes to go. What I'd like to do is just to take a couple of minutes here, maybe a bit less, just to try and summarize what I've been hearing, and that's going to be a bit of a challenge. Thank you both very much for some very interesting presentations which looked at similar problems, but from a different perspective, which I think is always very useful. As I mentioned before, we had one very focused business with a particular vehicle operating in a specific environment in the UK, which allowed a deep dive look at very specific problems, needing to engage with the entire regulatory service provider and operator communities. And on the other side, we have very ambitious project to implement a statewide UTM system with only what might be called a nascent industry underneath it who may find this useful. But the need is recognized that even at this stage, to enable drone operations of all types to happen, a great coordination is necessary between those same stakeholder groups. So the message number one is the need to cooperate, for all participants to cooperate, is paramount, and that you can't fight the regulator, you have to work with the regulator. You can't ignore other airspace users, we have to work with other airspace users. And these businesses don't have an automatic right to operate there. It's got to be safe, it's got to be done in such a way that it doesn't have a disproportionate impact on other users. Now, the technology side was much discussed. We have the detect and avoid question still very much unresolved. Yes, below 500 feet. Do you need it? Can you do it by SORA and by pre-planning? Is SORA going to be effective if you move from ones and tens of drones up to hundreds of drones or more? Is it going to be scalable in that way? It remains to be seen. And if we are going to have different technologies that can provide separation and or detect and avoid capabilities, then are these do they need to be certified in the same way? Do we need a new certification methodology? Do we need new networks, new communications, or can we do it with what we've got now? Are regulators too conservative? Good question that we need to look at. Are they right to be? Of course, I would say that they are for now, but can we move on? They need to change and move along, and the processes need to change. So I think you've raised a lot of really, really interesting questions, as the question and answer sessions have proved. I think what we can say now is that we're looking forward to hearing more from you after your next week, Libby, maybe. And so thank you very, very much indeed for prompting. Apologies to all those people whose questions didn't get answers. We'll do our best to get back to you. Please remember to complete the survey for the end of the event. We really do value your feedback. And please also do come to the next events, which are coming up in the coming days and weeks, and to hear more about what we have with the European U-Space network of demonstrators. So thank you, Nick, thank you, Libby, for the presentations, and thank all of you for coming and spending your valuable time today to hear what we have to present to you. Good afternoon, have a good week.